Hey guys, this is Mr. Grice for Algebra 2 Unit 3.3 Notes, Day 1. Today we're going to be talking about solving absolute value inequalities. Our learning target today is to be able to solve and graph absolute value inequalities and to write their solutions in interval notation. So, you ready to begin? Good, me too. So, if you look at the top, you see that it says less than, and that means and. Greater than means or. So when we're dealing with absolute value inequalities, okay, the absolute value and then inequality, if it's less than, we're going to change it to an and. And if it's greater than, we're going to change that to an or. And one way to remember that is if you say the word less than, and then we add the and. You're like, what? Trust me, this works. Okay. And the other one is great. Greater. Oh well, you'll get a hang of it. So let's take a look. The first thing I notice is that the absolute value is all by itself. Okay? There we go. Let's not pretend that's negative. So the absolute value of x plus 2 is less than 1. So what that means, if I'm going to change this to an and, that means that we have a positive 1, and then we also have a negative 1. Because it can equal two things, right? Yeah. And then all we do is solve. So I'm going to subtract 2 to both sides, or all three sides, and then we get negative 3 is less than x, which is less than negative 1. Okay? And this is what I'm going to use to graph. Okay? Let's see, I'm open at negative 3. I'm open at negative 1. And I'm going to shade the middle. And then when I take that into interval notation, our graph starts at negative 3 and is open, and the graph ends at negative 1 and it's open there too. Okay? So when you look at the inequality and it's less than, you're going to take whatever it's equal to, the 5y less than or equal to 10, but then we're going to make it less than or equal to negative 10 on the other side. And then we just solve. The solving part you guys are good at. Divide by 5, divide by 5, divide by 5. We get negative 10 is less than or equal to y, which is less than or equal to 2. Okay, so at negative 2 we are closed. At positive 2 we are closed. And for the and graphs, we always shade the middle. Okay, so I'm closed at negative 2, and then I'm closed at positive 2. Which means my answer, my solution, can be anything in the shaded region. Okay, so the absolute value is all by itself, and it's less than and. So we have 2 minus 7m less than 30, and I'm going to use the same symbol, and I'm going to change it to a negative 30. Okay, and then we solve. We have to subtract 2 to all three sides. So we get negative 32 is less than negative 7m, which is less than 28. Now I have to divide by a negative 7. And remember, all these rules, if we divide by a negative, we have to, that's right, we have to flip the sign. So then we get m, we get -4, and -32 divided by -7. I'm not too sure about that. I don't even know if that reduces. So let's double check. We got -32 divided by -7, and it's about 4.57, and it doesn't reduce, which is fine. So 32 over 7. That's right, we do have to rewrite this, okay? We had to flip and rewrite. So we get -4, which is less than m, which is less than 32 over 7, okay? Now, when I have to graph 32 over 7, I think it might be important to know, because we just did it in our calculator. Where is it? There it is. That it's about 4.57, because we have to graph it. Okay, so now that we have this guy right here, let's go ahead and graph. So at -4, I'm open. And then it's right about here. No, you're not closed. And we're open right there. And then I'm going to shade the middle. Okay, now we could say that right there that is 32 over 7. So we know exactly where we tried to put that circle, the open point. Okay, so interval notation, our graph begins at -4, and then it ends at 32 over 7. Right, example number 4. Inequalities, or the absolute values all by itself. And then we have a less than, okay? So that means less than or equal to 8, and then less than or equal to, technically greater than or equal to, -8. Okay, let's solve. So we're going to add 4 to all 3 sides. -8 plus 4 is -4. And 8 plus 4 is 12. Now to get the w by itself, we have to multiply by the reciprocal. And if you can't do that in your head, just do 3 divided by 2 times -4, and you'll get -6. And then we're going to do the same thing with 12. 3 divided by 2 times, no, not -12, it's a +12. And we get 18. Okay, so this is what we're going to graph. So here we go. At -6, we're closed. And then at +18, we're closed. And we shade everything in the middle. Okay, so at -6, it's a closed point, so we use a bracket. And then at +18, we're closed, so we use a bracket. Okay? All right. So if you notice, every time we did one of those, it was less than. Less than. Now we're going to do great or. Okay, so it's great or, which means I'm going to break this up into 2 ors, which means x minus 2. We remember how we set one to -5 and one is 5. So the one that's 5 is going to be greater than, but our other one is going to be less than. And then we solve. Okay? So we add 2 to both sides, and we get x is less than -3. And then on the other side, we're going to add 2 to the other side, and we get x is greater than 7. So there's my or. X is less than -3, or x is greater than 7. There we go. Okay, so at -3 I'm open and I'm less than, so I shade to the left. And then at +7 I'm open and I shade to the right. Okay? So when we're doing this in interval notation, remember it starts at -infinity and then we have the break until -3, or it goes to -3. Here's my or right here, that's our union. And then we go to 7 to +infinity. So now we're just going to write that. And everything's brackets because everything's open. And we don't have any close points. Okay, so remember, look at the sign greater. The absolute value is all by itself. So we have -10y is greater than or equal to 20. That's our first one. And the -10y is less than or equal to -20. I'm just going to move this guy over a little bit. And then I'm going to write my or. Okay, so I have to divide by -10. And when I divide by -10, I have to flip. So we get y is greater than or equal to +2. And then I'm going to do the same thing on with my other equation, inequality. Sorry. Y, we have to flip, and then we get -2. Okay? So this is my or statement, and then I'm going to write those two in order. Okay, and now that they're in order, it's going to be a lot easier to graph. So at -2, I'm closed, and I'm going to shade to the left. And then at +2, I'm closed, and it's greater than, so I shade to the right. So interval notation, -infinity to 2, and I'm closed. This is our break. And then 2 to +infinity. And the only thing that's different is with our closed points, we have to use the bracket. So -infinity to 2, sorry, -2. And then union closed to the +infinity. That's not that bad, is it? No. The hardest part is just remembering how to set it up. Okay? So always look. There's our inequality. It's greater. So I have the -8m plus 7 is less than or equal to -63. So I always flip it for the negative. Or -8m plus 7 is greater than or equal to 63. Okay, let's go ahead and solve. So we're going to subtract 7 to both sides. We get -8m is less than or equal to -70. And then to get the m by itself, I divide both sides by that's right, by a negative. So I have to flip. So we get the m by itself. And then I have -70 divided by -8, 8.75. Math, enter, enter. And it's 35/4. Okay, why don't you guys pause the video and see if you can solve the right side all on your own. Good luck. Okay, so you should have gotten m is less than or equal to -7. Remember, when you divide by negative, you have to flip. Okay, So I'm just going to write a quick note. We said that that was 8.75. So here we go. At -7, which is right here, we are closed and we shade to the left. In fact, I'm going to write right here that that's at a -7. And then over here, I'm at 8.75, which is not the middle. It's just a little before the middle. And I'm going to shade to the right. Okay? So we've done enough of these interval notations now that you should know when it's pointing to the left, it goes to -infinity. And then at -7, I'm closed. Our break is the U, the union, and then we're closed at 35/4, and it goes to +infinity. Okay, last one. So our inequality is all by itself, or our absolute, Mr. Grice, come on. Our absolute value is all by itself. It's greater, so I have 2 plus 4/3 W is less than -6, or 2 plus 4/3 W is greater than 6. So this is the one that I kept the same, and here's the one where I flipped it. Okay? All right, we're going to subtract 2 to both sides. We get 4/3 W is less than -8. And then to get the W by itself, we have to multiply by the reciprocal. Okay? So we get W is less than -8 times, in parentheses, 3 divided by 4, and we get -6. On the other side, we're doing the same thing, just a different number. Subtract 2 to both sides. 4/3 W is greater than 6 minus 2 is 4. And then we're going to times it by the reciprocal, multiply by the reciprocal. And we get W is greater than, I think it's 3, but let's just double check. And it is. Okay, so as we're graphing that, I'm open at -6 and I'm shading to the left. And I'm open at 3 and I'm shading to the right. Okay, so interval notation, we have -infinity to -6, and we're open. Union with +3 to +infinity. Okay, so just remember, if you have less than, that's when we change it to the and. If it's, oops, sorry. Come on now, Mr. Grice. If it's greater than, we're going to change that to the or, and then we solve. Okay? So if you're looking at our 3.3 practice, it looks like we're going back and forth between less than and greater than for all of them. So just make sure you're paying attention to which one is the or and which one is the and. Okay? All right, guys. Well, this is Mr. Grice signing off for Algebra 2, Unit 3.3 Notes, Day 1. Thanks for watching.